Hi everyone, I'm making a quick video on permutations and combinations today. So this will be very simple, and I'll try to cover each type. This is actually based on A levels permutations and combinations, but it's gonna help you for your undergrad and university, as well as your school, O levels, and in general, it's gonna help everywhere. So we're gonna keep it concise, but I'll try to explain all the basics as fast as I can. And yeah, just comment below if you have any other queries. So let's start. So what's the main difference between permutations and combinations? But before we begin, if you do like my content and if you want more help, you can consider supporting me on Patreon. It's patreon.com/CAI papers solved. Currently, we have 3 tiers. The second tier is the most popular, the one where you get access to all my solved papers and notes. And for the ultimate learning experience, you actually get access to one-on-one video meetings with me via Google Meet once or twice a month. And there's the first tier for general support. Anyway, let's begin. So what's the main difference between permutations and combinations? In permutations, arrangement actually matters. Okay, so in permutations, arrangement matters, but in combinations, arrangement does not matter. So for example, let's start with something very basic. I'm talking about permutations first. So let's talk about A, B, C. 3 letters. We are going to arrange them. So if they ask you what are the possible arrangements for these letters, so the answer will be 3 factorial. So what does factorial mean? So 3 factorial is essentially 3 times 2 times 1. Okay, so how did we actually get this? Or if you have your calculator, what does this mean? It's 3p3. So the P stands for permutation and the C stands for combination. So what does 3p3 mean? That means you have 3 blanks. Okay, you have 3 blanks and you are putting 3 letters or subjects into those blanks, which are all unique. Okay, so this is what 3p3 means. And about 3p2, what does 3p2 mean? That means you have 3 different subjects and you're putting them into 2 spots or blanks. Okay, so ABC, if I write down all the combinations, all the permutations, all the arrangements, it's like this: ABC, ACB, then we have BAC or BCA, and then we have CAB or CBA. So these are all the 6 possible combinations. Okay, and the way to get that is 3 factorial or 3p3. That's basically it. So we can apply this same concept elsewhere. Suppose if I have A, B, C, D. So since all 4 letters are unique, so the answer will be 4 factorial or 4p4. So as you can see, 4 factorial, if you have a calculator with you guys, so what does 4 factorial mean? It actually means 4 into 3 into 2 times 1, which is 24. And then again, 4p4 also means 24. It's the same meaning, just different notations. Okay, so if we go to another section like A, B, C, D, E, you guys should know the answer now. It's going to be 5 factorial basically. That's the number of combinations, sorry, number of arrangements, which is 120. Okay, moving on. So what if we have identical letters now? Suppose, check this out. What about A, B, B? So check this. Let's call this, for the sake of understanding, let's call this B1 and let's call this B2. So I have A, B1, B2, A, B2, B1. Okay, then B1, A, B2, B1, B2A, then B2A, B1, then B2, B1A. So the alarming point here is these two are the same, then these two are the same, and these two are the same, because the B's are actually identical, they're the same thing, so we can't actually consider them as different arrangements. Yeah, so basically what we do here, we have 3 letters, right? So it's going to be 3 factorial, but due to there being two identical letters, we have to divide that over here. So we are going to divide 3 factorial by 2 factorial. So we are going to get our final answer as 3, because this is basically 3 times 2 times 1, and this is 2 times 1, so we can get rid of this, so we get 3, or you can just use your calculator. So we can apply the same concept elsewhere. Like check this, A, B, B, C. So in total you have 4 letters, so for that I'm going to go for 4 factorial, but we have 2 repetitions, so I'm going to divide that by 2 factorial over here. Okay, so that is going to be our answer. 4 into 3 times 2 factorial by 2 factorial, so we get 12. Okay, let's move on to another example. For example, what if we have multiple repetitions, like A, B, B, C, C, D? So your first step will be to count all the number of letters. So we have 1, 2, 3, 4, 5, 6. So that's going to be 6 factorial divided by how many repetitions do you have? Careful, it's not 4 factorial, but rather 2 factorial times 2 factorial, because B's and C's are not identical, so you have to consider them separately. Okay, so it's actually 6 factorial by 2 by 2, which is 180. So all the sums that I'm doing right now is for the all possible arrangements. Okay, and we are dealing with permutations, not combinations yet. Okay, these are all permutations, where in the question they will ask you what are all the possible arrangements for these letters. Okay, does that make sense? So we're going to be dealing with numbers a bit later, like soon, but let's understand letters first. Okay, so this is the general idea. Now when you're doing questions on permutations, it is important to note whether they use the word identical. Okay, so for example, they might ask you that, like, let's make a question. You have 7 identical history books, 4 identical geography books, and you are asked to line all 11 books are lined up on a shelf. Okay, so what are the possible arrangements? So essentially same concept applies here, since they're identical. So you're going to do 11 factorial first, because there are 11 books in total, but then you divide by 4 factorial times 7 factorial. That's the general idea. So hopefully you understand. It's very straightforward, and in this way you can easily do all these sums. Now let's move on to a few harder concepts. Okay, so you'll be given questions where you're asked to line girls or boys, line them up. You'll be asked to line them up in a straight pattern, or they'll be asked to stand or sit down in a line. So you'll be given certain questions. For example, let's make a question right now that there are 7 boys, 4 girls. So let's start with all arrangements. So what will this be? Boys and girls are not identical. Each boy is unique, each girl is unique. So here the division does not really matter. So all arrangements without restrictions. Okay, all arrangements without restrictions. So we have 11 people, different unique people, so it's just going to be 11 factorial. That's the answer. Now they might ask you, they might say something, they might add the girls cannot stand next to each other. Girls cannot stand next to each other. Fine. So whenever you'll be given this sum that they cannot be next to each other, right? This is when it gets a bit complicated. So always remember, the ones who cannot stand next to each other, or the letters that cannot be next to each other, just exclude them completely. exclude them from the setup completely. So I'm not even considering the 7 girls. I just consider the sorry, I'm not considering the 4 girls. I'm just considering the 7 boys. Okay. So boy, 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 boy. So we have 7 boys. Fine. And they can interchange between each other, right? So that's just going to be 7 factorial. For the boys, it's 7 factorial. Now for the girls, they cannot stand next to each other. So they need to have a boy next to them, okay? So there's one spot here, another spot here, another here, another here, another here. So basically the arrows, the arrow method basically deals with this, where, you know, I put the girls in between the boys, okay? So as you can see, count the number of arrows. 1, 2, 3, 4, 5, 6, 7, 8. It will always be one more than the number of boys standing there. So it's 8. So you have 8 spaces, right? You have 8 spaces and 4 girls. So what will this be? And their arrangement matters, okay? So whenever arrangement matters, it's permutations P. So it's going to be 8 spaces and 4 girls, which is 8p4. So this will give you your answer, which is 7 factorial times 8p4. That is 8467200. Or you could do it this way: 7 factorial times 8c4 times 4 factorial. 8c4 times 4 factorial is the same as 8p4, because 4 factorial means the 4 girls can interchange between each other, and 8c4 means I'm just choosing the positions for the 4 girls and then I'm arranging them. But 8p4 does that in one step, essentially, okay? So that's that. Okay, yeah. There is a variation to this question. They could have said that, I'm showing you the variation. They could have said that the girls cannot stand next to each other, okay? And they cannot be on the ends. They cannot be on the ends of the line. So same variation, it's just that we'll exclude 2 arrows now. The ends will be empty. So for the boys, it's 7 factorial again. But for the girls, you have 1, 2, 3, 4, 5, 6 spots now. So that's 6p4, because arrangement still matters, okay? So this is another variation, okay? So we're still on the same question, but now I'll show you another variation. Now, find out the number of arrangements where the 4 girls stand together. All 4 stand together. Okay, this is another variation that you might face. So when they say that, you have to consider the 4 girls as a unit. So remember this very carefully. Remember my techniques. When they say that so a few things cannot stand next to each other, you exclude them completely and then put them in the arrows later on. But if they say that the girls need to be together, all 4 girls need to stand together. So you have to consider the 4 girls as a unit. So it's like G, 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 G. 4 girls will be considered as a single unit, and there will be 1, 2, 3, 4, 5, 6, 7 boys. So how many units do we have? We have 7 individual units over here and 1 unit over here. The girls are considered as 1 unit because they will move either here or here, here. Like as a unit, they'll be jumping in between the boys, okay? So basically, we have 8 units, so it's going to be 8 factorial for the 8 units. But the girls can also interchange in between them, so we are going to have a 4 factorial over here. So does that make sense? So you can apply this technique everywhere, trust me. Like this, just remember this technique and it will help you guys. I will show you more examples. Okay. And there can be another one. All 4 girls cannot be together. So guys, this is a bit different from the girls cannot be next to each other. What does the girls cannot be next to each other? What does that mean? It means that even two girls cannot be next to each other. Okay, that's the essential meaning. Like two girls can be next to each other, three girls can be next to each other, four girls can be next to each other. That's what the girls can't stand next to each other means. But here, when they say all four girls cannot be together, what does that mean? Only this scenario is excluded. But two girls can stand next to each other, or three girls can stand next to each other, but not all four. That's what this means actually. So watch out for this. So this is a bit different. You can't actually use the arrow method because that would take two or three girls into consideration as well. So to do this, you actually have to perform this first. You have to find out the arrangement where all the four girls are together on the line, and you need to subtract this from all possible arrangements. So the answer to this is all possible arrangements minus all four girls together. So that is 11 factorial minus 8 factorial times 4 factorial. That's the general idea, okay? So I'm going to do this with letters now because we just did it with people. Now let's do it with letters. Okay, so for example, let's make a question. So what question was this? We had question 1. This is question 2. I'm making another question. We'll be solving questions from the question papers. This is mainly based on A-level statistics, S1, but this will be applicable for each and every one because, you know, I had problems understanding permutations and combinations back in the day when I was in high school, class grade 9 and 10 basically. But in grade 11 and 12, I broke it down and understood it, and I'm going to try to do the same thing for you guys, because after you watch this, you know, 40 or 50 minute video or 1 hour plus video, you are going to have a clear concept of permutations and combinations. Just go through this every now and then if you ever get stuck. So question 3, let's start with the word permutations. Permutations. Okay, fine. So whenever you get a word like this, the goal is to write the letters down like this. For example, check this. What am I gonna do? So P, there are no more P's. There is only one E. There is only one R. There's only one M. Only one U. Permu. There are two T's, so I write them separately. There are two T's. There is one A, one I, one O, one N, one S. Okay. So the only repetition here is a T. And Permuaions, these are all unique. So what if they said, find out all the arrangements for the word permutations? What would it be? Okay, so at first you need to count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters, so 12 factorial. This is all arrangements. Divided by, since the T's are repeats, it's going to be divided by 2 factorial. So that is your answer. 12 factorial by 2, which is a very high answer. It's 239500800. Okay. Next, why don't we try this? T's have to be together. Okay, let's start this. So what did I tell you guys? Consider the T's as a single unit. So the T's will be one unit and the others will be individual units. So how many units do we have? We have 10 over here, 1 over here. So do it with me. 11 factorial, because we have 10 plus 1 units, 11 units. But now we have to consider, like, remember when I did the girls, the 4 girls can interchange in between, but they were unique, but the T's are not. So you can opt to not write them completely, or you can do this. So the T's are going to interchange between each other, but since they are identical, I'm going to divide it by 2 factorial again. So 2 factorial for the interchanging and divide by 2 factorial because they're identical. Okay, so that's that. You can choose to cross this out because the value is 1. So the answer is 11 factorial. Next, let's try t's cannot be next to each other. Now I'm going to teach you something very technical. Okay, so whenever you have 4 girls, that was the tricky part, but here you have 2 t's, only 2 t's. So listen to my question. The t's cannot be next to each other, the t's cannot all be together. They mean the same thing here because there are only 2 t's in the first place, right? So what does the t's not being next to each other mean? One t cannot be next to the other t. What does the t's cannot all be together mean? It means that the 2 t's cannot be together. But when would they have different meanings? If you had 3 or 4 t's, that's when it has a different meaning. All right, so here it's the t's cannot be next to each other or the t's cannot be together. Same meaning, but I'll show you 2 different ways to do it. Okay, so I'm going to exclude the t's completely. I have p, e, r, m, u, a, i, o, n, s. Okay, so we put down the arrows, and there you go. Because they did not say anything about the ends, so we're cool with that. So for permutation, per PERMUAIONS, it's going to be 10 factorial. They're unique. And the t's, how many spots do they have? I told you it's going to be one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. So that's 11. You have 2 options here. You can either go for 11p2 divided by 2 factorial, or the alternate is 10 factorial times 11c2. So why did I write c2 here? Because the t's are identical, their arrangement does not matter. That's why you can write 11c2. But if you want to do this technique, you can write 11p2, but then divided by 2 factorial because, it's they're identical. So it's 10 factorial times 11c2 on your calculator, which is 199584000. Moving on. Moving on to another technique or alternate technique. We have the ones for where they're together, and we also have all the possible arrangements. So I just want to show you the alternate root is, this is root 1, this is root 2. All arrangements minus t's together. So that is basically this value over here minus this value over here. And I'll actually show you that this is the same answer. Wait, 12 factorial by 2 minus 11 factorial. And I get 199584000. So that's confirmed. But remember, this is very, very technical. This is only applicable, okay? This is only applicable when we have two letters only, but not applicable when we have 3 or 4 identical letters, or girls or something like that. Then you have to do it manually. Like all cannot be together is something else, and cannot be next to each other is something else when you have more than 2 of a same thing. Okay, so that's more or less it. There is another one that I really like, another type of sum. So that was question 3. Why don't we do question 4 now? This is a question from a past year, released. So yeah, do it with me. So R, we have triple E. Write it like this always. Then you have L, A, S, T. R, L, A, S, T, and triple E. So all arrangements. Let's do this. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters. So that's going to be 8 factorial. But we have 3 E's as repeats. So divide by 3 factorial. That's it. Next. This is a harder variation. The letters LED, all arrangements, but the letters LED have to be in this specific order. So this is another sum that you'll face. So how many blanks do we have? 8. 1, 2, 3, 4, 5, 6, 7, 8. Whenever you get this sort of sum, you guys need to understand that you have to approach it manually. Okay, I'll show you what I mean in a bit. Let's approach it manually. Okay, so LED, the word letters have to be like this. Okay, and what other letters do we have now? We used L, D, and one E. So I have R, A, S, and double E. So this LED will be in this particular order. So I cannot change it. Like I cannot write DEL or ELD. It has to be LED. So I'm just going to keep it like that. Let it be. Let it be. And on the right hand side, you have these 5 letters. So for these 5 letters, what will be the arrangement? 5 factorial because 5 letters, but there are 2 repeats. So divide by 2 factorial. That's it. Now on the other hand, this was only one way to do this. Can't we arrange it in some other way? Like LED, then it could start from the third blank, LED. It would start from fourth blank, LED, LED, and this is it, LED. So in total, but this thing would be the same. Look, R, A, S, E, E. It would still be 5 factorial by 2 factorial for all of them, okay? So essentially, how? 1, 2, 3, 4, 5, 6. 6 ways in which you could do this. So you have to multiply it by 6. And that will be your answer. So whenever you get this sort of sum where they ask you that these particular letters have to be in a specific order, do it like this, manually with blanks, okay? Now there are a few other questions, but we'll be moving on to combinations next. Like you'll be asked to arrange people for a photograph, or you need to arrange adults in a line, etc. But we'll be solving those in the question papers, but these are the general ones. Now about numbers, let's do one with numbers and then we can move on to combinations. Okay, so moving on to question 5. Okay, so suppose you are given 1, 2, 3, 4, 5, 6, 7. You are asked to make a 4-digit number. No restrictions. Okay, 4-digit number, no restrictions. Numbers can be repeated. This is very important. Numbers can be repeated. If they ever say this, numbers can be repeated, it is not permutation. Because permutation actually means that if you use up a number, you can't use it again. That's what permutation actually means. So how many options do we have? 1, 2, 3, 4, 5, 6, 7. So you have 7 options here, 7 options here, 7 here, 7 here. So it's essentially 7 to the power 4. Okay. Let's go next. Sorry. Next, 4-digit number, but no repetitions. Whenever you say no repetitions, this is what permutation is. This is permutation. Because a permutation means that whenever you use up a number, you can't use it again. Okay, no restrictions though. So 1, 2, 3, 4. So you can use all 7 in the first blank, 7C1 or 7P1, whatever, or just 7. And then after you used up one number, suppose I've used up 2, now you have 6 options. Then I've used up another one, so you have 5 options, then you have 4 options. So this is basically it. 7 into 6 into 5 into 4. This is when you have no restrictions, but no repetitions are allowed. Okay? Okay, but what if we have some restrictions now? Suppose they can give you these sums. These are rare in A levels these days, but you can find these in undergrad or somewhere else maybe, if you have a math course, stat course. So no repetitions. Now we'll be dealing with no repetitions. No repetitions. but we need to make 4-digit odd numbers. 4-digit odd numbers, 1, 2, 3, 4, and this is our pool. This is our pool. Okay, so to be odd, the last number has to be odd basically. So it's either 1, 3, 5 or 7. 1, 3, 5, 7. So we have 4 options over here. 4C1, 4 options. But here it doesn't really matter. So you used 1 out of 4, 4C1. You have 4 options. You used 1. Suppose I used up 1. How many numbers do we have left? 1, 2, 3, 4, 5, 6. So 6 options over here, 5 options over here, 4 options here again. So it's basically 6 into 5 into 4 into 4C1. So that's how you do it. And the same thing, no repetitions, but suppose let's make a 5-digit even number. You can try this with me. No repetitions, but 5-digit even numbers. 1, 2, 3, 4, 5. How will you do it? Do with me. We need to identify the even numbers first. What are they? 2, 4, and 6. So the last blank has to be 3C1. Okay. And then what about the others? Suppose you used up 2. 1, 2, 3, 4, 5, 6. You have 6 options. So 6 options, 5 options, 4 options, 3 options. So that's 6 into 5 into 4 into 3 times 3C1 for choosing the odd even number at the end. Okay. So more or less this is what you'll face in numbers. You might have another condition. Okay. This is a bit complicated. Let's try this. Okay. This is the last variation that you might get. Okay. So no repetitions, 4-digit odd numbers greater than 3000. So this is the peak of difficulty for numbers that you might get. So 4-digit odd numbers, but it has to be greater than 3000. So basically the first blank cannot have 1 or 2 because it has to be greater than 3000. So it has to start with 3 at least. So at first let's start with odd numbers. Okay, 1, 3, 5, 7. These are the odd numbers, but we can't use all of them. I'll tell you what I mean. Okay, so you have to do it individually. Okay, what does this mean? Check this. So suppose if I put 1 over here, suppose I put 1 on the end, I made it odd. So the first blank can be 3, 5, or 7. And the middle numbers can be anything, you know, any number. Next, 1, 2, 3, 4. If I put in, sorry, I made a slight mistake over here. If I put 1 over here, the first blank, since it has to be greater than 3000, it can either be 3, 4, 5, 6, 7. So how many options do we have? We have 5 options. So 5 options, and we used up 1 over here. I used up 1, and suppose that I used up 3. Okay, and then we have 2 options. So 2 blanks left. 1, 2, 3, 4, 5. Okay, so 5 options again, and then 4 options because I used up another one. Kind of like this. And since 1 is sitting here, it's going to be 1C1. Basically kind of like that. Now you might be wondering, okay, so is there any different way to do this? Like the thing that I did over here, like 7 times 6 times 5. Yes, of course. There is another way. What does that mean? I prefer doing it like this, but the other way is, for example, in part B, 4-digit numbers, no restrictions, but no repetitions. So you have 4 blanks, but options 1, 2, 3, 4, 5, 6, 7 options. You could just go for 7P4. 7P4. 840. Same answer. As well as here, suppose 4C1 because it has to be odd. So either 1, 3, 5, or 7. You put that here, 4C1. And then you have 3 blanks, but 1, 2, 3, 4, 5, 6 options. 6P3 times 4c1. That would give you the same answer, 6p3 into 4c1, which is 480. But why do I not prefer doing that? Because of sums like these. Here, the actual problem starts. Because here you cannot apply permutations. You have to do it manually, yeah? Okay, so we are done with 1. Now let's start with another one. Why don't we do it with 5, for example? Let's start with 5. Or let's do it with 3 first. So I use 3 here. I made it odd. So what can I put in the beginning over here? Let me copy this, wait. So I used 3. So 3 is done. So to make it greater than 3000, we can use 4, 5, 6, or 7. So that is 4c1 on the first blank. So suppose I used up 4. Now how many do we have? 1, 2, 3, 4, 5. I have 5 options, but 2 blanks. So that's 5p2. And I put 3 over here, so that's 1c1. That's basically it. 4c1 times 5p2 times 1c1. Or you could do it like this. 4c1, you have 5 options, and then 4 options, and then 1c1, because you put in 3. See, it's the same answer. 4c1 into 5 into 4, which is 80. And on top, it's 4c1 times 5p2, which is also 80. And what about this? This was 5 into 5 into 4 into 100. Okay, let's go next. What if we put 5 at the end? Okay, so I used up 5, which means 1c1. And then to make it greater than 3000, what can I use here? I can use 3, 4, 6, or 7. So 4 options, 1 blank. So that's 4c1 or 4p1, anything is fine. So suppose we used up 3. How many options do we have? 1, 2, 3, 4, 5. So that is 5p2 in the middle. Okay. Or alternate route, 5 options for the first blank, 4 options for the second blank, and then 1c1. So 4c1 times 5 into 4 into 1, which is 80. As you can see, this is basically a repeat of this one. And if I use it with 7, check this, if I use 7 over here, same thing. To make it greater than 3000, 3, 4, 5, or 6, 4c1, and then 5p2 times 1. So yeah, it's the same for 3, 5, and 7, but it's unique for 1. The reason being, because we have access to one more number. We have access to one more number over here. 5p2. Which makes it greater than 3000, yeah? Because we're not using that up. So you could just do 80 times 3. So the final answer for all arrangements, for no repetitions, 4-digit numbers greater than 3000 is, you can either do 100 plus 80 times 3, or you can go for the individual route, 100 plus 80 plus 80 plus 80, which is 240 plus 100, 340 is your answer. So just take this in, see if you understand, and yeah, tell me if you have any other queries in the comments below. So yeah, we are mostly done with permutations. Now let's move on to combinations, shall we? So let's go. Combinations. So combinations is a bit tricky in few aspects. So you'll be mainly dealing with teams, committees, and you'll be asked to choose. Okay, you'll be asked to choose a few letters from a certain word, a group of 4, a group of 5, something like that basically. Okay, so let's start with the basic. So we are going to make a football team. We are going to make a football team of 11. So we have 4 goalkeepers, then 8 defenders. So what does combination mean? You need to understand that first, right? It's basically permutations without the arrangement. Okay, for example, ABC. I'm going to choose 2 letters out of these 3. So what are the possibilities? AB, AC, and BC. That's it. That is 3C2. I have 3 letters, but I'm choosing 2. 3C2, which is 3. Like if it was permutations, what would it be? It would be 3P2. It would be 6. Why so? I'll tell you why. Because AB and then BA, AC, CA, BC, CB, these would have been different arrangements. But here the arrangement doesn't matter. As long as you have AB or BA, that is considered as one single combination. Okay? That's the general idea. So 4 goalkeepers, 8 defenders, 7 midfielders, and 4 strikers. So we're picking a team of 11. So let's reduce the number of goalkeepers. Let's make it 2. So they've asked you that you need 1 goalkeeper, then 4 defenders, 4 midfielders, and 2 strikers. So you have to make a setup for this, okay? So let's do this. I'm just selecting. Select a team. If you see the word select, that usually refers to combinations. So 2C1 times 8C4 times 7C4 times 4C2. This is your answer. Selecting a team. That's a very basic, and yeah, that's that. Easy as that. This is the most basic question that you'll face. Next, let's move on to another one. We are going to make a committee. Suppose we are going to make a committee. We have 7 men, 5 women. We are making a committee of 5 people. At first, no restrictions. So here, consider everyone as equal individuals. You have 12 people. So no restrictions. What does that mean? 12C5. Just selecting 5 out of 12 people. Now, 5 people, but more women than men. So in these cases, you need to make a table like this. Women, men. So there have to be more women than men. So 5 people, right? We can have 5 women, 0 men. 4 women, 1 man. 3 women, 2 men. But yeah, that's it. These are all the possible combinations, yeah? So 5C5, I'm picking all 5 women and 0 men, 7C0. Plus 4 women, 5C4 times 1 man out of the 7, 7C1. Plus 5C3, 3 women and 2 men, 7C2. So if you do the math, 5C5 times 7C0, one way, plus 5C4 times 7C1, which is 35. 5C3 times 7C2, which is 210. That is 246. That is your answer. Next, you have another type of sum over here, where you have Mr. Jack and Mrs. Rose. They cannot be on the same committee together because they have an argument of sorts, so they cannot be on the same committee together. So there are multiple ways to do this. You can do it in 2 ways, okay? So way 1 is form the committee with them together and then subtract it from the total number of ways. Like the ones in the letters we did. All 4 girls have to be together, or all T's have to be together. Okay. Or you can make a committee with Mr. Jack, with Mrs. Rose, and without either of them, and then add it up. Okay. So I'm going to show you 2 routes. The one I prefer is route 1. So the committee with Mr. Jack and Mrs. Rose. Okay. So 5 people committee. So 1C1, I took Mr. Jack times, I'm taking Mrs. Rose. So I've already picked 2 out of 5 people. And now there are no other restrictions. So I've picked 2 people. I have 10 people left. And from the 10, I'm going to pick 3. So 10C3. This is the committee with Mr. Jack and Mrs. Rose. With Mr. Jack and Mrs. Rose. So Mr. Jack, Mrs. Rose cannot be on. Okay, so this is the one where Mr. Jack and Mrs. Rose have to be in the committee. In the team or committee. Okay. Now D. Mr. Jack, Mrs. Rose cannot be on the same team. So let's do this. So it's going to be all arrangements. So it's going to be this all arrangements minus Mr. Jack, Mrs. Rose on same team. So it's basically no restrictions. All, we shouldn't say arrangements, but rather all combinations. So that's 12C5 minus this one over here, 10C3. This is root 1. Now I'll teach you root 2, which is much more complicated. I personally do not prefer that. Okay, but it's much more complicated. So let's start. By the way, I'm sorry I couldn't get this video out faster for the ones who have a statistics exam today. I know I'm a bit late, I was a bit busy, but I plan to release this anytime, sometime soon. Anyway, so let's do this. None on team plus Mr. Jack on team, no Mrs. Rose, plus Rose on team, no Jack. So none on the team. So just exclude them completely. Exclude them. So we exclude 2 of them from the 12. So we have 10 people, and I'm going to pick 5. 10C5. None on the team. Next, I'm going to put Mr. Jack in. I'm going to ignore Rose. So we have 10 people, out of which I'm going to select 4. Then I'm going to put Mrs. Rose in, which is 1C1. I'm going to ignore Mr. Jack. And I'm going to put 4 others in the team from the remaining 10. So do it. You're going to get the same answer. 12C5 times 10C3. That gives you 672. And for this one, check this. 10C5, which is 252. Plus 10C4, which is 210. Plus 10C4, which is also 210. 210 times 2 plus 252. That gives you an answer of 672. So these are 2 routes to do this particular sum. Okay, we're almost at the end. Soon we'll be selecting groups of letters, and we have the one where we arrange people in cars. Okay. So let's do this. So we have 7 friends. And they're going on a trip, so we have 2 cars. One has 4 seats. Another has 3. So you're asked, how can you fit them in the car so that they can go on the trip? Arrangement does not matter. If arrangement matters, they'll let you know. How can you put them in the vehicle? How can they go on the trip? They might ask you this. So it's like this. We fill up the 4 seats first, like 7C4 times. Now we have 3 seats left and 3 people. So 3C3. Either this, or you can choose to fill up the one with 3 seats first. 7C3 times 4C4. That's it. There you go. Okay. So this is another one. So that's it, yeah. But if they said arrangement matters, it would have just been 7P4 times 3P3. That's that. Anyway, yeah, that's it. Now let's go to another one. Let's go with released again. But this time it's a bit different. RLASD, right? And triple E over here. You're asked to pick or select. The word is select. A group of 5 letters, okay? Or a group of 4 letters. 1, 2, 3, 4. And there has to be at least 2 E's. So the question is, at least 2 E's, and you need 4 letters, group of 4 letters, select. So let's try the number of arrangements. So double E and triple E, these are the possibilities, and we have RLASD. So since this is selection, you can pick 2 out of the 5. So it's going to be 5C2 here and 5C1. So that's it. If you add these 2 up, you'll get the answer, which is 15. The addition is 15. So I gave you a really easy sum, but we're going to be doing harder ones in the question paper now. I think let's begin. This is mainly directed towards A-level students, but I feel like everyone, any person who's stuck with permutations and combinations will benefit from the sums we're going to do, okay? So let's start with some questions. I think let's start from 2022. I'm going to be doing 2022, 2023, and 2024, all variants, hopefully. So let's do this, okay. So it's going to be very similar to the ones I taught you. Let's start. This is Feb-March 2022, variant 5.2. We have a group of 12 people, 3 boys, 4 girls, 5 adults. In how many ways can a team, whenever you see team, it's usually combinations. And if you see the word chosen, this is a keyword. If exactly 1 adult is included. Okay, so we have 1 adult. So the 4 other adults are excluded. So 1 adult from the 5, which is 5C1. And from the children, 7 children, you're going to pick 4, which is 7C4. That's it. In how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys and at least 1 girl? So this is kind of like the one where I taught you about, more women being there compared to men. But rather than that, you have at least 2 boys and at least 1 girl. So the same concept applies. You have to make a table. So it's a team of 5, at least 2 boys and at least 1 girl. This is the bare minimum. So 2 boys, 1 girl. To make 5, you need 2 adults. 3 boys, 1 girl, 1 adult. We have 3 boys in total, so we can't go above that. 3 boys, 2 girls, 0 adults, because they didn't say anything about adults here in the first place. So it's not necessary that we need an adult. Then we have 2 boys, 2 girls, 1 adult, or 2 boys, 3 girls, and 0 adults. So these are all the possibilities. You have to group them up like that, and then just do the basics. 2 out of 3 boys, so 3C2. 1 out of 4 girls, 4C1. 2 out of 5 adults, 5C2. Multiply them, and do it for the rest, and add up all of them to get the final answer, which is 248. I don't even get my own handwriting, but 120 plus 20 plus 6 plus 90 plus 12. Yeah, that is in fact 248. Yeah, good. Let's move on. Now the same groups stand in a line. Whenever you see a line, like as you associate teams with combinations, whenever you see a line, you should actually consider that it might be permutations. How many different arrangements are there in which the 3 boys stand together and an adult is at the end of the line? So what did I teach you? If some people stand together, they will be considered as 1 unit. Okay? So the 3 boys are considered as 1 unit. And other than that, we have 4 girls and 5 adults. The 3 boys stand together, and an adult is at the end. So how many units do we have? 1, 2, 3, or 5 adults, 4 girls. So that's 9 units over here, and 1 unit for the boys. So in total, that's 10 units. Okay. However, it's a bit tricky because the adults have to be at the ends. No other person, no other boy or girl can be at the end. So look at the blanks: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because there are 10 units. But the adults have to be at the ends. And since there are 5 adults, it's going to be 5p2. And since the adults are unique, that's why it's 5p2. If the adults were not unique, you would have to do a 5c2. Okay? But since they're unique individuals, so it's 5p2. And then in the middle, we have, what else do we have? We have the boys as a unit, then we have 4 girls and 3 adults left. We have 8 units left because we just added these 2 adults down. So 10 minus 2 is 8. So 8 factorial for them, since everyone is unique. And the boys can interchange in between them. So it's 3 factorial for them. So this was a pretty complicated sum. See if you guys get it. Okay, see if it makes sense. It is basically 5p2 because 2 out of 5 adults have to stand on the end and they are unique, so their arrangement matters. And then 8 factorial for the units in the middle. The 3 boys as 1 unit, and the 3 remaining adults and 4 girls, that's 8 in total. And 3 factorial for the boys, they can be interchanged as well. Okay, moving on to May June 2151. Question 1 and 2, let's do this. Find the number of different arrangements of the word deceived. So as you can see, what did I write on the right hand side? I wrote it down like DD, triple E, 1, 2, 3, and then CIV. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters in total. So that's all arrangements. Total arrangements is 8 factorial divided by 2 factorial times 3 factorial for the repetitions. So, but that's not what they asked. They asked in which all 3 E's are together and the 2 D's are together. All 3 E's are together and the 2 D's are together. So, how do we do this? All 3 E's are together. So for that, we have 3 factorial by 3 factorial. How many units do we have in total? CIV, 3 units. And then these are individually 1 unit each. So we have 5 units in total. So for that, we have 5 factorial. And then for the D's, it's 2 factorial by 2 factorial. And then for the E's, it's 3 factorial by 3 factorial. But this part is totally optional. You can choose to not write this at all, and then it would still be fine. Okay, do you guys understand? 120. Find the number of different arrangements of the 8 letters in the word deceived in which the 3 E's are not all together. Okay, so this is very important. This is what I taught you today in the beginning, in which the 3 E's are not all together. What does that mean? The E's can be next to each other, like there can be 2 E's next to each other, but the only restriction here is that 3 E's cannot be all together. So in this particular sum, the only way to do this is you have to find out the total number of ways, which I told you already is 8 factorial by 2 factorial into 3 factorial, and then subtract the number of ways in which all the 3 E's are in fact together. Then you will get this answer. Okay, so how to do that? Check this. You have a D, D, C, I, V, and then you have 3 E's. So how many units do we have? 1, 2, 3, 4, 5, and then 1 unit over here. That's 6 units. So 6 factorial for that. However, since you have 2 D's that are repeats, we are dividing that over here. 6 factorial by 2 factorial. And for the E's, it's 3 factorial by 3 factorial, which is again optional. So this is the number of arrangements where the 3 E's are all together. Now, if you subtract this answer, 360, from 3360, you're going to get your answer where you get all the arrangements where the E's are not all together. And if they ever said where the E's are not next to each other, you would apply the arrow method, which would have been DDCIV in the arrow method where they are not next to each other, I told you ignore the ones that cannot be next to each other. You input the other letters, which is 5 factorial by 2 factorial, and then you have 1, 2, 3, 4, 5, 6 arrows. So that's going to be either 6p3 divided by 3 factorial or 5 factorial divided by 2 factorial into 6c3, because the e's are identical anyway, so the arrangement doesn't matter. Okay. Next, let's do this. There are 6 men and 8 women in a book club. Now, the committee of the club consists of 5 of its members. Mr. Lan and Mrs. Lan are members of the club. In how many different ways can the committee be selected if exactly one of Mr. Lan and Mrs. Lan must be on the committee? So, either one. So, let's do this, but not both. So, I chose Mr. Lan, which is 1C1. And how many people do we have in total? 6 plus 8, which is 14 people. But I chose Mr. Lan already, and Mrs. Lan can't be on the committee. So we are going to go with 12 people. Out of 12 people, I have to choose 4. And for the other one, I took Mrs. Lan in, which is 1C1. And from the remaining 12, because I have to exclude Mr. Lan, it's going to be times 12C4, which is 12C4 times 2, or 990. The other ways, you can find out the total number of ways, which is 14C5, and then subtract 2 committees from this. One where we have both of them, and one where we don't have either of them. So the one where we don't have either, we exclude those 2 and we choose 5 from the remaining 12. And the one where we have picked both of them, which is 1C1 times 1C1, and from the remaining 12 we pick 3. But I prefer this method more, it's much better. In how many different ways can the committee be selected? Combinations again. If Mrs. Lan must be on the committee, and there must be more women than men on the committee. Okay. So, more women than men. As you can see, we did this type of sum. Make a table. And women, men. 3 women, 2 men. 4 women, 1 man. And 5 women, 0 men. But there's another condition. Mrs. Lan must be on the committee. Okay. So, Mrs. Lan is already included. So, that's 1C1. She's always there. Okay. She never misses. And from the 4 people, we need more women than men. So, 4 women, 0 men, 3 women, 1 man, and 2 women, 2 men. Why is this possible? Because we already have Mrs. Lan. So, she's actually adding 1 more to the woman over here. So, from the woman, which is 7, I'm taking 7 women because I have already taken Mrs. Lan. From the 7, I'm picking 2 women. And from the 6 men, I'm taking 2 men. Here, we don't talk about Mr. Lan because that was the condition in part A, not the condition in part B. So, it doesn't really matter here. So, yeah, then we take 3 women from the remaining 7 and 1 man, and then 4 women from the remaining 7 and 0 men. Okay, so if you add all of these up, you are going to get your answer 560. A bit complicated. Next, moving on to Major 2022-52. This was a hard sum actually. The sum over here, we have a word crocodile. So, crocodile. So, you have the word, this is Major 2022-52. Paper 52. You have CC double O, then RDILE. I wrote the word like that. All arrangements. So, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters divided by 2 repetitions. 2 factorial for C times 2 factorial for O. 90720. Next. Find the number of different arrangements of the 9 letters in crocodile in which there is a C at each end and the 2 O's are not together. Important. So, whenever I tell you that the 2 O's are not together, since there are 2 letters, it actually has the same meaning as the O's are not next to each other. Same meaning. So, whenever you get that, you ignore that letter completely. Do you get what I mean? You ignore that letter completely. Okay, there's a lot of working here, but it doesn't matter. Let me simplify things for you guys, okay? It won't take long. There's a lot of working here for some reason. Okay. So crocodile, right? I ignored the O's. C C O O R dial. I'm ignoring the O's for now. So how many blanks do we have? 1, 2, 3, 4, 5, 6, 7. I put the C's at the ends. So for them, it's just going to be 2 factorial by 2 factorial, or you can ignore them because they're the same thing. Next, R dial. R dial is going to be at the center. R D I L E. So that is 5 letters, which is 5 factorial, unique. And now for the O's, check this. The O's cannot be next to each other, so they will be in between these letters, but they cannot be at the ends either. So I've taught you this, so we skip them. So you have 1, 2, 3, 4, 5, 6 spots. Okay, so 6 spots, so 6 C2 because they're identical, so you don't need permutation. Or you could go for 2 factorial by 2 factorial into 5 factorial into 6p2 by 2 factorial. Same thing, okay? It doesn't really matter. It doesn't really matter, okay? It's that 1800 is your answer. And I told you that when you have 2 letters, you can actually opt for the other method where you can keep them together and then subtract from the total number of possibilities. That is also possible. So the total number of possibilities here is a bit different because the C's have to be at the ends, and this is a condition. So I keep the C's at the ends, and in the middle we have 7 letters, R dial plus 2 O's, that is 7 factorial by 2 factorial in the middle. And then if you keep the O's together, how many units do you have? 5 for R dial, and the 2 O's will be considered as a single unit. So 6 units, 6 factorial times 2 factorial by 2 factorial, because the O's are in fact identical, and you can ignore that. Okay, and then if you subtract 6 factorial from 7 factorial by 2 factorial, you'll also get 1800. But personally, I don't prefer this method. Whenever I see that 2 letters are there, or if I see the wording that these letters cannot be next to each other, I always apply the arrow method. Okay, that's my word of advice for you guys. Next, 4 letters are selected from the 9 letters in the word crocodile. Personally, this is one of the hardest questions in my opinion. This C and D, and a lot of people have been saying that maybe there's a mistake in part D in the mark scheme, like maybe it should be 65, like the mark scheme has been updated or something. If anyone knows, please do comment below if you have the updated mark scheme. Okay, yeah, so find the number of selections in which the number of C's is not the same as the number of O's. Fine. So for this type of sum, you also need to make a table. We are making a selection of 4 letters. Okay. As you can see, we have 4 letters over here. Then the no restrictions, but the number of C's is not the same as the number of O's. So it can be 0C 1O, 0C 2O, or 1C 0O, 2C 0O, or even 1C 2Os or 2C 1O. The number just can't be the same. Like it can't be 0 0, it can't be 1 1, it can't be 2 2. These are the red flags. Okay. So I just input that over here. 1C 2O, 2C 1O. Then we have 1 2C 0O 2O 0C 1C 0O 1O 0C. Okay, so 1 2 3 4 5 6 of them, and for the remaining blank we have to input R dial inside R dial. So that is basically for here it's 5C1 5C1 5C2 over here, and 5C3 for these ones basically. Yeah, so in total we have 50. So that's that. Now let's move on to the next one. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different group. So this is a rather difficult variation, which is pretty rare. I haven't seen this much. but yeah, a lot of people have been saying that the mark scheme has been updated and the new answer is 65 rather than 80. So if you guys know where to get that, please do comment down below. Like, I don't think you can comment down links, but just tell me the website where I can get it if the mark scheme has been updated. Because a lot of people have been saying that this 30 should be 15 and the total should be like 65 or something like that. Okay, so let's try to figure this out. So we have to divide crocodile into 3 groups. So there are 9 letters, so if you divide it into 3 groups, it's 333. Okay, so each group containing 3 letters, if the 2 C's must be in different groups. So okay, I'm calling it as group 1, 2, 3. So in the first one, I'm keeping group 1C, in the second one 1C, and in the third one 2 O's. And then we can keep 1 O with each C, 1C, 1 O, 1C, 1 O. And then we can keep 1C individually, like alone, then 1 O with 1C and another O alone. And then for the last one, 2 O's with a single C, and then we have 1C alone, and in the third group we don't have anything. So these are all the possible combinations that I've written down over here. So as you can see, you can check this out. Okay, these are all the possibilities. Now I just divided them up in the groups. So over here we have 4 variations. 1C with both O's, 1C alone, nothing. 2 O's alone, 1C, 1C individually. Then an O with each C. And then finally an O with a C, 1 O alone, 1 C alone. Okay, and we have R dial. Okay, so if you put R dial in, what will you get? It's 5C2 times 5C3, or the other way around, 5C3 times 2C2, or 5C2 times 3C3. You get 10. And then here you get 5C1 times 4C2 times 2C2. Okay, and then in group 3 you get 5C1 times 4C1 times 3C3, and in group 4 you get 5C1 times 4C2 times 2C2. So here's the thing though, in group 2 and 3, do you see a resemblance? Like, these 2 groups are identical, and here also these 2 groups are identical. So due to there being identical groups, and this is the combination, that's why we have to divide by 2 factorial, because this is the same thing. So probably there should be a 2 factorial down over here as well, and this should be 15, and the total should be 65. This is what I said while solving this paper in my channel. But yeah, in the mark scheme that I linked in the description, I do have 80 given, but I personally think it should be divided by 2 because it's the same group. So if you guys get an update, please do comment below, and I'll then update the description in my original video. But yeah, it should, then if you add them up, you get the final answer. But it's very rare. This is the first time that a question like this came in the first place. So yeah, that's that. Anyway, let's move on to Major 2022 5.3. Question 7. A group of 15 friends visit an adventure park. The group consists of 4 families: Mr. and Mrs. Kenny and their 4 children, Mr. and Mrs. Lizzo and their 3 children, Mrs. Martin and her child, Mr. and Mrs. Nantes. The group traveled to the park in 3 cars, one containing 6 people, one containing 5 people, and one containing 4 people. The cars are driven by Mr. Lizzo, Mrs. Martin, and Mr. Nantes respectively. In how many different ways can the remaining 12 members be divided? Whenever they say this, the arrangement does not matter. This is what I was talking about when I was describing all types of sums. So the position of Mr. Lizzo, Mrs. Nantes, and Mr. Nantes and Mrs. Martin is fixed. So we have 12 people left. So the cars, how many seats do they have? One containing 6, one containing 5, one containing 4. Okay. So this car has 6 seats in total, but the driver is already there, so you have 5 seats left. Here you have 4 seats left. Here you have 3 seats left. So it's going to be 12C5 times 7C4 times 3C3. Or you could fill this up first. 12C4 times 8c3 times 5c5. You can pick any one. It's just that after after you've taken 5 people, you have to reduce the pool by 5. 12 minus 5 is 7. Just make sure you do that. Okay. Any particular pattern works. Next, the group entered the park by walking through a gate one at a time. In how many different orders can the 15 friends go through the gate if Mr. Lizzo goes first and each family stays together? Okay. So Mr. Lizzo will go first. This is the entrance. And in the Lizzo family, we have Mrs. Lizzo and 3 children. So in the Lizzo family, you have Mrs. Lizzo and 3 children. So Mr. Lizzo is the first man. So for the other 4, you have 4 factorial. Okay. And then suppose I take the Kenny family. There any arrangement can be possible. 4 children and 2 parents. So that's 6 factorial. And then for the Martin family, we have only 2 people. So that's just 2 factorial. And for the Nantes family, we have just the parents. So that's 2 factorial. Okay. However, there's another part. There's a 3 factorial. Why? Because the Kenny family, the Martin family, and the Nantes family, they can interchange between each other. Like ABC interchanging between each other. So that's 3 factorial. I'm not taking Lizzo family into consideration because Mr. Lizzo has to be the first man entering. So that cannot be interchanged as the families have to go together. Okay. So this is the general idea. In the park, the group enters a competition which requires a team of 4 adults and 3 children. In how many ways can the team be chosen from the group of 15 so that the 3 children are all from different families? So this is chosen combination. So in how many ways can the team be chosen from the group of 15 so the 3 children are from different families? We need 4 adults and 3 children. So any adult works. How many adults do we have? Mr. and Mrs. Nantes, Mrs. Martin, Mr. and Mrs. Lizzo, Mr. and Mrs. Kenny. 1, 2, 3, 4, 5, 6, 7 adults. So any 4 from those 7 adults, okay? And from the 3 children, we have 4 children over here, so 4C1. 3 children over here, that's 3C1, and 1 child. Mrs. Martin has 1 child, so that's 1C1. So from the Lizzo family, anyone. From the Kenny family, anyone. And from the Martin family, anyone. So if you multiply these, you get your final answer as 420. 1 child from each family. In how many ways can the team be chosen so that at least one of Mr. Kenny or Mr. Lizzo is included? Okay. At least one. That means either Mr. Kenny only or Mr. Lizzo only or both. So we can do something. We can find out the team where Mr. Kenny and Mr. Lizzo are not included and then subtract it from the total number of ways. Okay. So total ways. Any 3 children out of 8 children, 4, 5, 6, 7, 8 children, any 4. And from the adults, from the children, any 3, 8C3. And from the adults, 4, 7C4. That's the total number of ways. Now, number of ways where neither Mr. Kenny nor Mr. Lizzo is chosen. Okay. So the children, right, will be the same. It will still be 8C3. And we're going to exclude both of them from the pool of the adults. So it's going to be 5C4 now. That's 280. Now, if you subtract 280 from 1960, you're going to get the number of ways where you have at least one of Mr. Kenny or Mr. Lizzo. Or both of them, basically, yeah? Or the alternate way is there, which is much more complicated, adding 3 scenarios individually. So I don't prefer that, honestly. Moving on to ON 2022-51. The 15 members are having their photograph taken. They stand in 3 rows. Oh, this starts here. A social club has 15 members, of whom 8 are men and 7 are women. The committee of the club consists of 5 of its members. Find the number of different ways in which the committee can be formed from the 15 members if it must include more men than women. Okay. So, more men than women. So, for example, you need 5 members in total and more men than women. So, 5 men, 0 women, 4 men, 1 woman, or 3 men and 2 women. These are it. These are all the possible combinations. So 8c5 times 7c0 plus 8c4 times 7c1 plus 8c3 times 7c2. These are all the possible combinations, okay? Next, we are going to take a photograph now. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. In how many different ways can the 15 members of the club be divided into a group of 3, a group of 5, and a group of 7? Fine. So here the arrangement does not matter. We are just dividing them into groups, like the sum with the car, okay? So you can start with any row. Suppose I started with the front row. 15c3 times 12c5 middle row times 7c7. It is the same as starting with the back row. 15c7 into 8c5 into 3c3. You will get the same answer, which is 360, 360. Okay? Next, in one photograph, Abel, Betty, Callie, Doug, Eve, Freya, and Gino are the 7 members in the back row. In how many different ways can these 7 members, we're just dealing with the 7, be arranged so that Abel and Betty are next to each other and Freya and Gino are not next to each other? So common technique that I tell you guys is that, you know, the ones that cannot be next to each other, completely ignore them. So I am completely ignoring Freya and Gino. They are out of the picture currently. And Abel and Betty, since they are going to stand next to each other, I'm going to consider them as a unit. So Abel, Betty, 1 unit. And then Callie, Doug, Eve. So how many do we have units in total? 3, 1. So that's 4 units in total. So for 4 of them, it's going to be 4 factorial. And for Abel and Betty interchanging, because they're unique, we have another 2 factorial. And then now for Freya and Gino. 1, 2, 3, 4, 5. 5 spots, but 2 people. 5p2, because they're unique, so it's 5p2, not 5c2. So always remember, the arrows, deal with them at the end. The ones who cannot stand next to each other. Always deal with them at the end, okay? Moving on to ON 2022-52. Oh yeah, guys, if you want access to all of these solved papers with the explanations on the side, you can consider supporting me on Patreon. I'll drop a link in the description. It's just $20 a month. You get access to all my stuff for science, physics, chemistry, bio, and math, as well as P3 and yeah, others. I'm considering launching another tier actually, where you can get access to 1 subject only, which might be affordable for a lot of guys, because $20 might be a bit too much, but maybe for $5 you could get access to 1 subject, you know, maybe. So that might help. Anyway, let's start with number 7. Find the number of different arrangements of the 9 letters in the word alligator, in which the 2 A's are together and the 2 L's are together. Okay. So alligator, double A, double L, and Igtor, I-G-T-O-R. So 2 L's and 2 A's are together. So in total, how many units do we have? These 2 A's are 1 unit, these 2 L's are 1 unit, and 5 over here. So 7 units, which is 7 factorial. Yeah, and you can just ignore the rest, because the A's can interchange, but they're the same. So yeah, that's that. Same thing. Next, the 9 letters in the word alligator are arranged in a random order. Find the probability that the 2 L's are together and there are exactly 6 letters between the 2 A's. Okay. So firstly, this is a very complicated sum, because its probability, it consists of 5 marks. So the A's, how many letters are there in total? If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 blanks. And then I start with 1A at the beginning, since then 6 blanks, 1, 2, 3, 4, 5, 6 over here. And then the A will be on the 8th blank over here. And the alternate one for this is, like, the A starts from the second blank and it will be on the 9th one. Only then there will be 6 letters in between. Okay, so this is the possibility for A's. Either the A will be on the first one and the 2, 3, 4, 5, 6, 7, 8th one, or A will be on the second one and the 9th one. In this particular way, you can only have 6 letters in between. Okay, next. So we just ignored the A's because we put them over there. But since there are 2 roots, I'm going to multiply that by 2. Because I can arrange the A's in 2 ways. Either first and 8th or second and 9th. That's that. Next. The L's are together. So they will be considered as a single unit. They will be considered as a single unit. So how do we do this? We have Ictor, right? Let's use a different color. IGTOR. Okay, so we have 1, 2, 3, 4, 5. So for these 5 letters, I'm giving 5 factorial. Okay, and then for the L's, look in how many ways can I just input them. 1, 2, 3, 4, 5. They can't be on the end actually, because I only have 1 blank on the end, right? So this 5 factorial is for IGTOR, this 5 is for the number of ways that I can put the L's, and this 2 is for the arrangement of the A's, because the A could also be on the second and last blank. Do you get what I mean? For example, the same thing would apply over here. Look, the L's, they would have 5 spots. Check this. I just want to make things clear for you guys. It could be over here, it could be over here, it could be over here or here. It's 5 ways for the L's. 5 ways for the L's. For IGTOR, it's 5 factorial. And why do I multiply by 2? Because this thing and this thing, right? Same thing, 5 into 5 factorial, but it's into 2 because the A's have 2 positions. So this is the number of arrangements where the A's are at the ends, and the A's have 6 letters in between them, and the L's are together. Next, since they wanted probability, we need to divide by the total number of events. So what's that? It's alligator, right? So 9 letters in total, but divided by 2 factorial for the L's and 2 factorial for the A's. So as a result, we have 9 factorial by 2 factorial into 2 factorial. We actually get 1200 by 90,720. Next. Find the number of different selections of 5 letters from the 9 letters in the word alligator, which contain at least one A and at most one L. So we need to make a table again. We are selecting 5 letters. So at least one A. So we need 1 A or 2, can't be 0, and at most 1 L. It will either be 1 or 0. So 1A 0L, 2A 0L, or 1A 1L and 2A 1L. Remember, when you have repetitions, you have to deal with them separately, and since we're dealing with them already, you can't consider them twice. I'll tell you what I mean. For example, I pick 1A and 0L, then I completely ignore the A's and L's. I only deal with IGTOR, IGTOR. I have 4 blanks but 5 letters, so that's 5C4. Then 2 A's and 0 L's, I ignore the L's completely. From IGTOR, I choose any 3, 5C3. 1A, 1L, 5C3. 2 A's, 1L, 5C2. If you add all of these up, you get your final answer as 35. Okay, so let's move on to ON 2022-53 now. Question 6. Okay, so find the number of different arrangements of the 9 letters in the word activated. So yeah, it's double A. I'll show you. Double A followed by double T, and then we have CIVED. So 9 letters, 9 factorial divided by 2 factorial and 2 factorial for the double A and double T. Next, what do we have? Find the number of arrangements in the word activated in which there are at least 5 letters in between the two A's. So we did a sum like this where there were 6 letters in between the two A's. So let's see this. So 9 letters, right? So 9 blanks basically. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we need 5 letters in between the A's. So 1, A, then 1, 2, 3, 4, 5. Then the A will be here. So similarly, what other arrangements do we have? Here you go. So there are 3 ways in which we can do this. Second blank and over here, third blank and over here. There you go. So they, in the question, they said at least, right? In the question, they said at least 5 letters between the two A's. Okay, so that means you can have more than that. So this is the arrangement for at least 5 letters. You could have 6 letters in between. Like check this. First blank, 6 gaps, then an A, or it could be on the second one and the 9th blank. And then you could also have 7 letters in between them where the A's are on the first and last blank. So after you input the A's, what else do you have? You have 7 letters, out of which you have 2 T's that are repeats. So basically it's 7 factorial by 2 factorial times 3, because there are 3 arrangements for 5 letters in between. And here it's 7 factorial by 2 factorial times 2 for 6 letters in between. And here it's just 7 factorial by 2 factorial times 1. So after you add up these values, you get your final answer, which is 15120. See if that makes sense. Okay, next, let's check this out. 5 letters are selected at random from the 9 letters in the word activated. Find the probability that the selection does not contain more T's than A's. So the number of A's, the number of T's cannot be more than A. They can be the same but not more. Okay, so we can have 2 A's, 2 T's, 2 A's, 1 T, 2 A's, 0 T, or 1 A, 1 T, 1 A, 0 T's, or 0 of each. This was the tricky one, which a lot of students may have missed out on. On the other hand, the ones that are not accepted are 2 T's, 0A, 2 T's, 1A, 1 T, 0A. These are the red flags, okay? You can't have those. So we are choosing 5 letters, so I put 5 blanks, and then I just input these, right? 2 A's, 2 T's, 2 A's, 1 T, and so on. 2 A's, 0 T's. There are in total 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I just input those. Now this sum is a bit different from the ones we've done beforehand, because look at this. Here they're asking for find the probability. Okay, find the probability. That's the important point. So in the previous sums, what was the question exactly? Let me show you. Then we can actually find out the difference. Here, find the number of different selections. So in this particular sum, we did not deal with the A's or L's anymore. But here they said that we are selecting a few letters and then find the probability. So if you ever find a sum like this, then the repetitions do matter. Because here, if we have more than one A available, that will actually have an impact, because we are dealing with all possible scenarios, okay? So what's the difference over here? Obviously from CIVED, we're going to put 3 letters over here. So it's going to be 5C3. However, we are going to take these A's into consideration. What does that mean? Since I've selected 2 A's, it's going to be 2C2. And here, it's going to be 5C2 for CIVED. And here, I've picked 2 A's out of 2 and 1 T out of 2 T's. So that's 2C1. And here I've picked 1A out of 2A's. That's why it's 2C1 and 5C4 over here. So you might be wondering, okay, so why are you considering them here? What's the impact that they have? Like, why didn't you consider them in the previous sum that you did? Okay, you might be wondering this. Sorry. So the general idea is, in this particular sum, the selections, the probability does not matter. So we are just dealing with one particular scenario. It doesn't matter whether the thing will repeat or not. But here, that has impact because we are dealing with all possible events. So obviously, like if you're picking this A, if we consider this as A1, there was a chance that we could have picked the second A2. So that actually has an impact, which is why this probability actually doubles. The number of events doubles. That's the idea. So here we have 1A, so 2C1 times 1T, which is 2C1, and then 5C3, okay? And then here it's 5C1 for CIVED, and 2C2 times 2C2. And the one where we have 0A's and 0T's is just going to be 5C5. That's it. So if you add all of these up, these are the successful events. Now if you divide by all possible events, which is selecting 5 letters from the 9-letter word, which is 9C5, you are going to get this answer as 43 by 63. So that's that. Okay, so we are done with 2022. Let's move on to 2023, March 2023. Okay, variant 5.2. Okay, so we are dealing with the word delivered. Fine. By the way, guys, I'm planning to launch a statistics course soon. A paid course, of course, but that will cover the whole A-level syllabus. Like from top to bottom. We'll have around 20 videos with question paper solving, just like this, all topics, as well as explanations, solving the course book, etc. So yeah, it'll be worth the money, and hopefully you can get an A star after you see the course. So if you're interested, please do comment below, then I'll be launching that soon. Okay, so we write it down as double D, then triple E, yeah, followed by LIVR, liver. There are in total 9 letters. Find out the different arrangements in which the 3 E's are together and the 2 D's are not next to each other. So I've repeatedly told you guys, when they say that some things are not next to each other, just ignore them. So I'm ignoring the D's and I'm keeping the E's as a unit. So I have 4 units here, 1 unit here, so in total 5 units. That's 5 factorial. For the E's, it's 3 factorial by 3 factorial. We can ignore that. And for the D's, the spots are, look at the arrows, 1, 2, 3, 4, 5, 6. So it's going to be 6C2 because the D's are identical. Or 6P2 by 2 factorial if you want the longer route, yeah? Or you could find out the total number of ways and subtract it only because there are 2 D's. If there were 3 or 4, it wouldn't have been possible, okay? Next. Find the probability that, like, you could find out the total number of ways and the number of ways where the D's are together and then subtract it from the total number of ways. This is only possible because there are 2 D's. The same wouldn't be possible for 3 E's because I've explained this at the beginning of our video, yeah? If you're seeing this question paper solving video only, you can refer to my, permutations and combinations video, the tutorial. I've explained it there. Anyway, find the probability that a randomly chosen arrangement of the word delivered has exactly 4 letters between the 2 D's. So the contrast from the last one, October-November 2022, variant 5.3, is that there we had at least 5 letters. Here we have exactly 4. So you write down the arrangements like this and just shift the positions of the D's. And we have 4 over here. And then we have, except these 2 D's, 7 letters, out of which 3 are repeats. So 7 factorial by 3 factorial times 4, because 4 arrangements. That's a success. So careful about the word probability. If you have this, you need to divide by the total number of ways, which is 9 factorial divided by 2 factorial for the D's and 3 factorial for the E's. So that's 30240. So for probability, success divided by all possible events, which is 1 by 9. Next, 5 letters are selected from the 9 letters in the word delivered. Find the number of different selections if we include at least 1D and at least 1E. Okay, so 1D, 1E, 1D, 2E's, 1D, 3E's. Then 2D's, 1E, 2D's, 2E's, and 2D's, 3E's. These are all of the possibilities. And since it's not probability, we just, consider LIVR. So from LIVR, 4 letters, 3 will sit here, so that's 4C3, and over here we will have a 2 out of the 4, that's 4C2, and over here 4C1, then 4C2, 4C1, and so on. For the last one, it's 4C0. If you add all of them, you will get the total number of ways. Okay. Moving on to the next variant. Major 2351. Cocooned. Question number 3. Find the number of different arrangements of the 8 letters in the word cocooned. So it's double C, triple O, and any D. There are 6, 7, 8 letters. So 8 factorial divided by 2 factorial for the C's and 3 factorial for the O's. Find the number of different arrangements in which the first letter is O and the last letter is N. Okay, fine. So we keep the first letter as O and the last letter as N. So in between we have 6 letters now, out of which there are 2 C's and 2 O's. So it's going to be 6 factorial divided by 2 factorial times 2 factorial. So a common question that I used to get from my students in the past was, okay, so we are keeping one O here and one N here. The O is being selected from 3. Does it really matter? Not really. When you put that O there, its work is done. You are only dealing with the other 2 now, okay? Next, find the probability that a randomly chosen arrangement has all 3. Oh, so this is probability, conditional probability. Has all 3 O's together, given that the 2 C's are next to each other. So here the condition is that the 2 C's are next to each other. Okay, so let's find that out first. The 2 C's are next to each other. So consider them as a unit. How many units do we have? 6 plus 1 over here, that's 7. So 7 factorial divided by 3 factorial for the O repetitions times 2 factorial by 2 factorial. So that's the condition, given that 2 C's are next to each other. Now we have to find the probability of the success, that we have all 3 O's together as well. So how many units now? 1, 2, 3 over here for any D. 4 units, 5 units. So 5 factorial times 2 factorial by 2 factorial times 3 factorial by 3 factorial. This is totally optional because they are identical. You don't need to show this, okay? So the success over here for all O's being next to each other, all O's being together, not next to each other, is 5 factorial, and below we have 7 factorial by 3 factorial. That's that. Okay. Do we have anything else? Oh yeah, we do. Question 2. Find the number of ways in which a committee of 6 people can be chosen from 6 men and 8 women if it must include 3 men and 3 women. Okay. So 6C6 from the men and 8C3 from the women. That's it. A different committee of 6 people is to be chosen from 6 men and 8 women. 3 of the 6 men are brothers. Find the number of ways in which the committee can be chosen if there are no restrictions on the numbers of men and women, but it must include no more than 2 of the brothers. Alright. No more than 2. So you can have 1 brother or 2 brothers, but not 3. Okay. So the easy way to do this is we are going to find out the committee with 3 brothers and then subtract it from the total number of ways. So suppose I've taken all 3 brothers. Now I have 3 other men left. So 3C3, I've taken all the brothers. And then I have 3 men left and 8 women. So that's 11 people in total. From the 11, I'm going to pick 3. So that's 11C3. And the total number of ways is, irrespective of the brothers, 6 plus 8 is 14. So 14C6 minus 3C3 times 11C3. So we get 2838. And the complicated route is doing 0 brothers, 1 brother, and 2 brothers in individually. So ignoring all 3 brothers, I have 3 men and 8 women. So that's 11 people. 11C6. Okay, 0 brothers. And then we have, I'm taking 1 brother out of the 3. That's 3C1 times 11C5, 5 others. And then I'm taking 2 brothers, which is 3C2 times 11C4. That also gives you an answer of 2838, okay? Next, moving on to May June 23, paper 5-2. We just have one question, I guess. Yeah. So, oh yeah, if you want access to all these are actually available on Patreon just for $20 monthly subscription. So yeah, you can actually solve alongside me, because in the mark scheme the answers are only there most of the time, but here you have detailed working of how I did everything. So yeah, it's gonna be very helpful for your exams, especially in the next May June 2025 series. Yeah, and I'm looking forward to you guys supporting me there. Also, I plan to launch another tier where you can get access to one subject only for like $5 per month. That's gonna be very popular, I think. Anyway, in a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. Each person competes in only one of these sports. So, a team of 7 people is selected from these 25 people to take part in a competition. So it's like the one where we selected the football team in my example, right, initially. So exactly one swimmer, at least 4 cyclists, and at most 2 runners. So runners can be 2, 1, or 0, and cyclists can be 4 or more. So one swimmer for sure, and then suppose we have 4 cyclists and 2 runners, that's 7. Then we can decrease the number of runners and increase the number of cyclists, so 5, 1 or 6, 0. And then you know the rest. 6C1, 1 swimmer out of these 6, then 8C4 times 11C2, and so on, okay? Moving on. For another competition, a team of 9 people consists of 2 swimmers, 3 cyclists, and 4 runners. The team members stand in a line for a photograph. How many different arrangements are there? If the swimmers stand together, cyclists stand together, and runners stand together. So there are 3 groups in total. For them, we have 3 factorial. For the 2 swimmers, we have 2 factorial. For the 3 cyclists, we have 3 factorial. And for the 4 runners, we have 4 factorial. Notice how I'm not dividing by 2 factorial, 3 factorial, or 4 factorial, like the previous sums with letters. The reason being, these guys are all identical, okay? How many different arrangements are there of the 9 people if none of the cyclists stand next to each other? Okay, so I told you again that whenever people can stand next to each other, just ignore them. So you have 2 swimmers and 6 runners, so that's 6 factorial. And then you have 7 arrows, but 3 cyclists, so that's 7p3, because their arrangement matters and they are not identical, okay? It's that. Moving on to May June 23, paper 5-3. So Casablanca. Find the number of different arrangements of the 10 letters in the word Casablanca in which the 2 C's are not together. Okay. So they're not next to each other basically. So we're going to ignore them. So Casablanca, right? 2 C's, 4 A's, SBLN. So I'm ignoring the C's, so I have 4 A's and SBLN. That's 8 factorial divided by 4 factorial because of the repeats. Then times, I have 9 arrows, as you can see. 9 arrows. 1 more always. So that's 9C2 because the C's are identical. Or you could find out the number of arrangements where the C's are together and then subtract from the total, okay? Next, find the number of different arrangements of the 10 letters in the word Casablanca, which have an A at the beginning, an A at the end, and exactly 3 letters between the 2 C's. Okay. So A at the beginning and A at the end. So I fixed that initially. Then I start with the C's, the arrangements. 1 C on the second blank, 3 gaps, then another C, and so on. I can do this in 4 ways. So I'm going to multiply it by 4. And how many letters do we have in the middle? We have 2 extra A's and SBLNs, so that's 6 letters. For that we have 6 factorial. And for the 2 A repetitions, we're going to divide by 2 factorial. So that's that. We're getting 1440, okay? That's it. Next, 5 letters are selected from the 10 letters in the word Casablanca. Find the number of different selections in which the 5 letters include at least 2 A's and at most 1C. Okay, so at least two A's. So it has to be 2, 3, or 4, and at most 1C. So C can be 1 or 0. So for 2 A's, 0 C's, 2 A's, 1 C, 3 A, 0 C, 3 A, 1 C, or 4 A, 0 C, 4 A, 1 C. And for the other blanks that are empty, we are going to use the letters S, B, L, N. So 4C3, 4C2, 4C2, 4C1, and so on. So the total answer is 25. Okay. So that's that. Moving on to ON2351. We don't have much variance left. We have 3 on this end and 7. 10 more sums approx. Hopefully this is very productive for you guys. If you want more of this content, please comment below. And if you like the content, please remember to like the video, share with your friends, subscribe to the channel. It actually helps a lot with the algorithm. I really want to reach 100k subs. We are at like how many subs right now? 21k or something? Kind of like that, I guess. Yeah, we're 21k 700, but a lot of you don't subscribe to the videos, honestly, and that actually breaks my heart. Because I'm doing this just for you guys. I'm almost done with med school. I'm going to be done this November. But yeah, I still want to continue this till I get 100k. And then I'll see what I can do. Maybe I'll leave. But so every subscription matters, okay? So please try to support me, guys. It actually means a lot. If you can't on Patreon, then just at least support me on YouTube. Thank you. Okay, so in a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y. Rajid, Sue, and Tan are 3 of these friends. The 8 friends will be divided into 2 groups of 4, 1 group for table X and 1 group for table Y. Find the number of ways in which this can be done if Rajid and Sue must sit at the same table as each other, and Tan must sit at the other table. Okay. So basically, here's the thing. Suppose Rajid and Sue, it wasn't specified whether they sit on table A. Okay, table X. So it can be on table X or table Y. That is why I have an into 2 over here. Okay. That's the first thing you need to know. Next, Rajid and Sue must sit at the same table as each other. Fine. So I make them sit at table X. So we have 2 more slots available and 5 friends, except Rajid, Sue, and Tan, of course. So for the 5 friends, we have 2 seats. So that's 5C2, and their arrangement doesn't matter because they just asked how can they be divided, yeah? And then we have 3 seats left at table Y, so we can just go for 3C3. You could opt to fill up table Y first. You could go for 5C3 times 2C2. That would give you the same answer. Now, why did I multiply by 2? Because Rajid and Sue could also sit at table Y, and Tan could sit at table X. That's why it's multiplied by 2. That's the general idea. Next, when the friends arrive at the restaurant, Rajid and Sue now decide to sit at table X on the same side as each other. Tan decides that he does not mind at which table he sits. Find the number of different seating arrangements for the 8 friends. Fine. So, Rajid and Sue decide to sit at table X. Okay, it's fixed now. And on the same side. And now Tan decides that he does not mind at which table he sits. So he can either sit at table X or Y. So this is a bit complicated. Let's try to break this down. Okay, this is a bit hard. Come on. So Rajid and Sue, suppose I make them sit on this side of the table, okay? Table X, this side, same side. So we have 6 remaining friends and 6 seats. So 6C2, I make 2 people sit here, and then 4C4, I make the other 4 sit on the other table. Because Tan doesn't mind. Tan's being the good guy, okay? Everyone be like Tan. Don't be like Rajid and Sue, okay? Next. What about now? Because they use the word arrangements, okay? So students, whenever you see the word arrangements, that's when permutations come in, okay? So why do we have 4 factorial? Why do we have 4 factorial? This is the important part. Because of these guys over here. 4 factorial because these 4 guys can interchange their positions. Okay, the 4 people we sat at table y. Okay, next, this 4 factorial is for the 4 that sat at table y. What about this 2 factorial? The first 2 factorial is for the other 2 friends that sat at this side of table x. Okay, so there you go. And what about this 2 factorial? This is for Rajit and Sue because they only decide to sit at the same side of the table, which is here, but they can interchange their positions. And what about this 2? This is because Rajit and Sue can also sit on this side of the table. So that's the basic idea. So 6c2 times 4c4 times 4 factorial for these guys, 2 factorial for these guys, 2 factorial for these guys, and times 2 because Rajit and Sue could also sit on this side as long as it's the same side of the table. Okay, hopefully you guys understood. It's 2880. Moving on. As they leave the restaurant, the 8 friends stand in a line for a photograph. Find the number of different arrangements if Rajit and Sue stand next to each other. So they're probably dating, guys, because they can't leave each other. Okay, so Rajit and Sue stand next to each other, but neither is at the end of the line. Fine, okay. So we have 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. So Rajit and Sue, they're together, so they will move as a unit, but not at the ends. The first one and last one, they can't stand there. Okay, so they have 1 position, 2nd and 3rd blank, 3rd and 4th blank, 4th and 5th, 5th and 6th, 6th and 7th, but they can't occupy the 8th one. So in total, 1, 2, 3, 4, 5 positions. Now for Rajit and Sue, there's a 2 factorial because they can interchange places. And for the other 6 friends, we have 6 factorial. So it's pretty straightforward. 6 factorial times 2 factorial times 5, which is 7,200. That's that. Okay. I prefer this method because it's like you can visualize. In permutations and combinations, always try to visualize your answer. Always try to visualize the arrangements. It will help you guys a lot, trust me. Okay, ON2352 now. Yeah. Let's go. Question 7. I will say one thing though, the permutations and combinations for stats have progressively become more difficult over the few years, okay? So let's do this. Andromeda. It's the name of a galaxy. So one variation I missed while I was teaching initially was that of vowels and consonants. So Andromeda, double A, double D, Enrome. No consonant is next to another consonant. Okay. So what are the vowels here? We have 2 A's, 1 O, and 1 E. So, okay, for the vowels, we're going to ignore the consonants first because they said they can't be next to each other. So, for the vowels, it's 4 factorial by 2 factorial due to the A's, which are repeats. And then we input the consonants, which are D, D, R, M, N. So, we have 5 arrows and 5 consonants. So, that's 5 factorial, 5p5 or 5 factorial, divided by 2 factorial because there are 2 identical D's. That's that, 720. Next, find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at each end and the D's are not together. Okay, so there's an A at each end, fine. And in the middle, we actually have, I'm going to ignore the D's, right? Because they're not next to each other. So we have Enrome in the middle. So that's 5 factorial for Enrome. And for the D's, we have 1, 2, 3, 4, 5, 6 arrows, the blue arrows. I'm not considering the N's because those are occupied by A. So that's 6c2 or 6p2 by 2 factorial if you want that root. The other way was you could subtract the D's being together from the total number of ways where the A's are then, but I don't personally prefer that, okay? Next, 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability. Oh, this is probability again. Just like that sum we did, activated, same. I think it was this one, yeah. ON 202253. We have that again, ON 2352. Find the probability that this selection of 4 letters contains at least 1 D and at exactly 1 A. So we have 2 A's and 2 D's. So exactly 1 A. 1 A and at least 1 D. So 1 D or 1 A and 2 D's. So So there are some other blanks left where n room can be allocated. So here it's going to be 5c2, here it's going to be 5c1. And for these, since it's probability, the number of a's and d's do matter. So here we're picking 1a out of the 2, so that's 2c1, and 1d out of the 2, that's 2c1 again. And here it's 2c1 times 2c2 times from n room 1 letter out of the 5, that's 5c1. Okay, there you go. 25, that's 50. And since it's probability, we need the total number of events in the denominator. So picking 4 letters out of 9, which is 9c4, we get 25 by 63. Moving on to the last variant in this year, 2023. Let's do this. Jay and his wife, Kaz, are having a party. Jay has invited 5 friends and each friend will bring his wife. Okay. At the beginning of the party, the 12 people will stand in line for a photograph. How many different arrangements are there? Of the 12 people, if Jay stands next to Kaz and each friend stands next to his own wife. So there are 6 couples. For that we have 6 factorial. And for each couple, they can alternate their positions. So 2 factorial into 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 2 factorial, or 2 factorial to the power 6. So that's 6 factorial for the 6 couples, the 6 units, times 2 factorial to the power 6. That's the answer. How many different arrangements are there of the 12 people if Jay and Kaz occupy the 2 middle positions in the line? With Jay's 5 friends on one side and the 5 wives of the friends on the other side. Okay. So Jay and Kaz occupy the 2 middle positions. So there are 12 spots for 12 people. And the middle spots are 1, 2, 3, 4, 5, 6. The 6th and 7th spot. So Jay and Kaz want to be here. The 5 friends, Jay's 5 friends on one side, and the 5 wives on the other side. So for these 5 friends over here, it's going to be 5 factorial. For the 5 wives, it's going to be 5 factorial. And for Jay and Kaz, Jay can either choose to be beside his friends, or Jay can either choose to be beside the wives. Which Kaz would not like very much, by the way. But it's still a possibility. So that's 2 factorial for them. Okay, 2 factorial for them, 5 factorial for the guys, the bros, and 5 factorial for the wives. And why this into 2 here? Can you guys figure out? Because the wives and Jay's friends can also interchange their positions. This one and this one, right? These are also interchangeable. That is why we have an into 2. Next. For a competition during the party, the 12 people are divided at random into a group of 5, a group of 4, and a group of 3. Find the probability that Jay and Kaz are in the same group as each other. Okay. So this is like the word crocodile, like Majon 202252, but with people instead. So we have 3 groups, a group of 5, 4, and 3. So we are going to consider Jay and Kaz in the group of 5 people, then in the group of 4 people, then in the group of 3 people, and so on, like this, okay? So Jay and Kaz being in the group of 5 people, then we have 10 people left. So 10c3 times 7c4 times 3c3, that's 4200. Jay and Kaz in the second group, that's 10c5 times 5c2 times 3c3, 2520. And then Jay and Kaz in the last group, so that's 10c5 times 5c4 times 1c1, that is 1260. So the total number of ways in which Jay and Kaz are in the same group are 7980. And what about the total number of events anyway? We are just selecting people, right? So that's 12c5 times 7c4 times 3c3 down below. That is 19 by 66, okay? That is all. Okay, moving on to 2024. I don't have all the variants done here, and we don't have October November 2024 out yet, so that's another issue. So I might be launching this video later, the one where I solve all the ones from 2024. Let's see, because when October November 2024 is out. And we're starting with Feb March 2024 paper 5.2. Okay, let's go. I might do another video on probability, by the way, just like this permutation combinations. So if you do like this, please like the video, subscribe to the channel, and comment below if you want one on probability as well. We're gonna be doing a speed run on all the sums. Okay, so let's do this. A new village social club has 10 members, of whom 6 are men, 4 are women, and the club committee will consist of 5 members. Okay. In how many ways can the committee of 5 members be chosen if it must include at least 2 men and at least 1 woman? So in total 5 people, 2 men and 1 woman at least. So 2 men, 3 women, then 3 men, 2 women, or 4 men and 1 woman. So that's that. 6c2 from the men times 4c3 plus 6c3 times 4c2 plus 6c4 times 4c1, 240. The 10 members of the club stand in line for a photograph. How many different arrangements are there? If all men stand together, all women stand together. So there are 2 units, and for that we have 2 factorial. And for the men we have 6 factorial. For the women we have 4 factorial. That's 3, 4, 3, 3, 4, 5, 6, 0. Okay. For a second photograph, the members stand in 2 rows with 6 on the back row and 4 on the front row. Ollie and his sister Petra are 2 of the members of the club. How many different arrangements are there of the 10 members in which Ollie and Petra stand next to each other on the front row? So this is the arrangement. 6 on the back and 4 on the front. Okay. And Ollie and Petra. Ollie doesn't want to let his sister Petra be alone, so they're going to stand together. Now what options do they have? They can either stand on this end, in the middle, or on the right hand side. So honestly, there are 2 ways to do this. Number 1 is the manual approach. So basically the 8 other members, they can just interchange their positions. So we have 8 factorial for them. Ollie and Petra can interchange their positions. We have 2 factorial for them. And 3 because they have 3 positions on the front row. So 2 times 3 times 8 factorial. Next here. What is the other technique? So this is a bit more complicated. I prefer this. I would go for this. I think this is what they did in the mark scheme. I did this manually. So in the mark scheme, they did this. So they picked 2 people out of the 8 for the front row. So that's why we get 8c2. And 6 people go on the back. That's 6 factorial for the back. And on the front, we have 2 people out of the 8. That's 8c2. And times 2 because Ollie and Petra can interchange their positions. And why do we have a 3 factorial? Because there are 3 units here. Ollie and Petra as a single unit, and the 2 guys we put on the front. So they can interchange their positions. That's why we have a 3 factorial, okay? Or the other route was, basically, we could just do 8p2. What does that mean? Out of the 8 people, we could pick any 2 and make them sit over here with arrangement, because they can interchange their positions. 6 factorial for the ones in the back. Okay, and times 3 factorial because there are 3 units over here. But rather than this is much better personally, because this makes sense. I pick 2 out of the 8, make them sit here. 3 factorial for all these guys. 2 for Ollie and Petra, and then 6 factorial for the back, basically. Okay? Next. Moving on to May June 24, variant 5.1. I don't have this done actually, but we can do this together now. So we actually have numbers here. That's something new. Let's do this. So this is May June 24, variant 5.1. Come on. How many different arrangements are there of these 8 digits? Okay, so numbers after a really long time. The last time I saw this was like 2013 or 14. So we have 1, 2, 2, 3, 4, 4, 4, and 5. They're arranged in a line. So we have 8 numbers in total. That's 8 factorial divided by 2 repetitions and 3 repetitions over here. So 2 factorial times 3 factorial, which gives us an answer of 3360. Great. Next, find the number of different arrangements of the 8 digits in which there is a 2 at the beginning, a 2 at the end, and the 3 4s are not all together. This specific wording is so damn important because this means that 2 can be next to each other, but not 3 altogether, okay? So we have to do all together, we have to find out all fours together first and then subtract, or else this won't happen. Okay, so at first let's do all three fours together. How? So sorry, 2 at the beginning, then 1 2 3 4 5 6, then over here we have 2 at the end. Then suppose the fours are together. Wait, I'll use another hide marker. Whoa, wait. So we have 4 4 4, and we have 3 other numbers, right? 1 3 5. So this is the number of arrangements with the fours together. What will it be? So we ignore the 2's completely, or you could do 2 factorial by 2 factorial, ignore. And in the middle we have 3 plus 1, 4 units, so that's 4 factorial. Oh yeah, that's it, times, ignore the 4's as well, you can ignore them, I just wrote it. Okay, and now we're gonna do the arrangements, all possible arrangements with 2's at the ends. Okay, so 2 over here, 1 2 3 4 5 6, then 2 over here. So we have 4 4 4 and 1 3 5. So this is just the number of arrangements with 2's at ends, but no restrictions on 4. Okay, so let's do this. So for the 2's, just ignore, and for here you just have 6 factorial by 3 factorial. So now you can find out the number of arrangements where the 2's are at the end and the 4's are not together. How? So it's 6 factorial by 3 factorial minus 4 factorial on top. So you get your final answer, which is 96. So hopefully I could make this clearer. This was a bit complicated. Okay. Next. 3 digits are selected at random from the 8 digits. Find the probability that the 3 digits are all different. Okay. Let's do this. There are multiple methods to do this actually. There are some complicated methods and there are some easy methods. Let's start with the easy one. Because only the 2's and 4's are repeats, and 1 3 5, they are just, you know, they're unique. So I'm gonna make one for 2's, one for 4's, and one for 1 3 5 because they're unique. So let's do this. So what if I have 0 2's, 0 4's, and all 3 of these? That's gonna be unique, right? Because these are 3 different numbers. So that's 3C3. I am picking this. Okay. So what is the answer for this? It's going to be 1. 3C3 is 1. And then we can have 2 of these and 1 of this. Or we can have 2 of this and 1 of this. 0 over here. Or we can have 1 2, 1 4, and any one from these 3. Do you get what I mean? So check this. Now the main part comes into play. So this one will be like, out of these 3 I'm picking any 2, 3C2, and out of the 4's, how many 4's do we have? We have 3 4's, so 3C1. Then over here we are picking 2 again, which is 3C2, 2 from 1 to 1 3 and 5, and 1 from the 2's. We have 2 2's, that's 2C1. So that's 6, this is 9, and this is 1. And here I'm picking 1 from each. So 3C1 from 1 3 5, 2C1 for the 2's, and 3C1 for the 4's. So ultimately we are getting 18. Okay. So if you add all of these up, you're going to get your total number of selections, which is 56. Okay. So now we are going to find out the probability. So in probability, we have all possible events below. So we have 8 digits in total. So I'm just picking any 3 out of those and 56 on top. So this gives us a final answer of 17 by 28. Okay. There are other ways to do this, but very complicated. Like individually finding them out. I'll talk about this more when I do this variant individually, Magen 2451. Until then, this should do. Okay, let's move on to the next one, Magen 2452. Regenerate. Do we have anything else? No, we don't. Okay, so for regenerate, let's do this. We have 2 R's, triple E, no, 4 E's actually. Then G N A T, NAT. So 10 factorial for the 10 letters, 2 factorial for the R's, 4 factorial for these, since they are repetitions. Okay, that's good. That's 75600. Next, how many different arrangements are there of the 10 letters in which the 4 E's are together and the 2 R's have exactly 3 letters in between them? This is hard. Let's see how to do this. Okay, so we have 1 2 3 4 5 6 7 8 9 10 over here. So suppose I put the E's at this end. They can't be in the center because we need 3, right? And then suppose I have R over here, 1 2 3 letters, and an R over here, and these E's over here are gonna be 1 unit. Okay, so let's go next. Another route is like we can keep the R over here and R over here. So this is the general idea. And what letters do we have? NAT, G, and AT. So they're gonna be sitting over here. Okay, but what about some other scenarios? Like, take a look at this. Basically, what if I show you this? Wait, 1 2 3 4 5 6 7 8 9 10. Wait. So the E's could be on this end too, right? 1 2 3 4 as 1 unit. There you go. And the R's could be over here, like 3 letters in between, 1 2 3 over here, or 1 2 3 here. Oh, okay, so there could be another possibility. Like, check this. Suppose if I have the R's here, 1 2 3 R over here, I could have the 4 E's over here right beside them too, and 1 other letter over there, right? Does this make sense? There could be another gap over there, right? And similarly, we can apply it over here as well. Like, check this. I can keep these R's over here, R over here, 1 2 3 R over here. I could keep the 4 E's here and then another gap. So actually there are 6 distinct scenarios like this. Okay, and I think it's best if I just do this. Wait, this one, which ones match? Wait, I'm making the match. Here, okay. And then we have these. Fine. Okay, that's good. And last but not least, these 2 scenarios. Fine, looks good. So this is the way to do it. So again, for NAT, the 4 letters, it's just going to be 4 factorial. And for the 6 distinct scenarios, it's going to be 6. So that gives you an answer of 144. They did do it in another way. They just wrote 4 factorial times 3 factorial, which is also 144. My one is also accepted, but they did it in another way. Okay, so I can't exactly figure out what they did, but you should try to do these sums in this manual approach. It is much better for you guys. You won't make a mistake then, okay? So it gives you the same answer. Find the probability. Okay, so it's probability that a randomly chosen arrangement of the letters in the word regenerate is one in which the consonants and vowels alternate, so that no two consonants are next to each other and no two vowels are next to each other. Okay, so it's 4 E's, right? And we have net and 2 R's. So what are the consonants here? Consonants, vowels. The vowels are E, 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 and A. And over here we have R, R, G, and T. Fine. Okay. So what if I do this? What if I input the consonants R, R, G, and T? And the vowels will go here. Like, none of them can be next to each other. Neither the consonants nor the vowels. So suppose if I consider this arrangement, this is fine, okay? 5 factorial by 2 factorial. But why is considering 6p5 wrong? Because look, I can get the vowels here, 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 and here. Then what would happen? These R's would be next to each other. So whenever you have these, that they have to alternate, they can't be next to each other, you can't consider this arrow over here. They have to fill up these particular spots. So it's actually a bit different. It's like this: R, R, G, and T. And over here we have E, 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 and A. So for the vowels, we also have 5 factorial divided by 4 factorial though. But we are going to multiply the whole thing by 2 because it could start like this. It could start with the consonants, right? Like R, R, G, and T, and then followed by E, 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 A, kind of like this. So that's why there's an into 2. There are 2 ways of doing this, okay? Next. This is probability, so we need to find out the total one below. So this gives us an answer of 600. So 600 divided by total number of ways, which we found out, right? 75,600. 75,600. This is the probability. So that actually gives us an answer of 1 by 126. Okay, so interesting sum and another different variation that we understood. This is a very much needed, okay? Next, moving on to the last variant. I actually have this done as a paper, but we'll still be solving the permutations. How many different arrangements are there for the 9 letters in the word recorders? So triple R, double E, and chords. So that's 9 factorial divided by 3 factorial times 2 factorial. How many different arrangements are there of the 9 letters in which there's an E at the beginning, E at the end, and the 3 R's are not all together? Okay, so we need to do 3 R's together. This is just like this one, the one we did over here. This one, it's just like this. So R's together as one unit and then subtract from the total number of arrangements where the E's are at the ends. So E's at the ends, R's together as a unit, and chords. So 5 units, that's 5 factorial. And here, all arrangements with E's at the ends, that's 7 factorial by 3 factorial. So if you subtract this from this, you will get the answer, 720. Next. The 9 letters are divided into 2 groups, a group of 5 letters and a group of 4 letters. Find the probability that the 3 R's are in the same group. Okay, so 2 groups of 5 and 4. Since there are repeats of E as well, we need to consider them separately. Okay, so look at the groups, yeah? So group 1 and group 2. So 3 R's over here with 2 E's, 3 R's over here with 1 E here, 1 E over here, 3 R's over here, double E's over here, or we could have the 3 R's in the second group. So 3 R's over here with 1 E with them and 1 E over here, or 3 R's over here without any E's. That's the general idea. These are all possibilities. This is another new type of sum, okay? So R's in group with 5, R's in group with 4. So if you fill it up with the other letters, which is chords, so 4C4 over here, then what will this be? 4C1 times 3C3. But look at how I multiplied this by 2, because this E could have also been over here, and since this is probability, I keep on telling you, whenever there's probability, number of repeats do matter. Like the word activated, right? Like with the word over here, Andromeda, find the probability. The number of repeats do matter. Then over here, activated, right? These sums, okay? This is from ON2253, and this is from ON2352, and this is from Majun 2453. So that's why I multiplied by 2C1, because we could pick any E for each group. And then over here, we have cods, right? So that's 4C2 times 2C2. And over here, we have 4C4 times 2C1 again, because the E's, there are two E's in different groups. So it's double the events. And over here, it's 4C3 times 4C1 times 3C3, or 4C3 times 1C1. Same thing. It will give you an answer of 4. So these are our successes. That's 21. And the total number of ways is this. Right, so for the total number of ways, it is just dividing them into two groups, like the sum with cars. 9C5 times 4C4, we get 126. So that's that. So the probability is in fact 21 by 126, or 1 by 6. This was a hard sum. So the alternate route for this is a much simpler approach for successes. We can just divide the r's over here. That's 6C2. And then just consider the e's over here. That's totally fine. So like cods and 2 e's, that's 6 in total. So 6C2 times 4C4. And over here, it's going to be, 6C1 times 5C5. If you add these up, you get 21. This is not suggested though, because there are only 2 e's over here, so we could get away with it. Maybe if there were 3 or 4, we would have an issue. So it's best if you always do it like this. In that case, you won't get wrong answers. Okay, this is a much safer bet, but this is also okay in this case, because there were only 2 e's. Okay, so guys, that was it for the whole video. It was a, how long is this? 2-hour 36 video in total. So if you watch this whole thing, you will probably master all of permutations and combinations for A levels, and permutations and combinations in general. Hopefully I could help you guys. I tried to discuss all possible variations for you. If you like the video, please remember to like this video, subscribe to the channel, share with your friends, and if you want more content like this, please do comment below. And don't worry, I'll be solving the ones for October, November 2024 once they're out as well. And I might be doing one on distributions, binomial, geometric normal, as well as, probability soon, if this gets a lot of reach. Okay, guys, thank you for tuning in. See you guys in the next one. Bye-bye. Take care.